So it is if so once again if anyone is wanting to like is new to the session, we are sponsored by Domestica. So and there these are the prices for that are based on attendance in classes. So yeah, everyone who is new here, if you attend all the lectures or all the classes, it will you will get different prices based on where you place. There is like Domestica Plus subscriptions for a year or 6 months. And there is also notebook on the prices. This will be a more of a question oriented session in total. So this will be a question. This is a question on what we did before. So what will be the answers to this question, for example? So the first question is -4 plus 3 iota minus 6 minus 7 iota. So we join. It is good, right? Yeah. So if we see, this is basically a normal addition, and it's this is the basic test of the first question. The second question that was given, it is about multiplication. So it is basically multiply. So it would be 6 plus 8 iota minus 9 iota minus 12 iota square. This will basically become minus 1. So you can see that it is 18 minus alpha. This one. This is basically what we did in the first lecture, and we saw the interpretation through the graph. So this is basically a point -4 comma 3, and this is the point 6 comma -7. When we add these 2 points, it will come as when we subtract these 2 points. So this is a subtraction between the points. So it will be basically we shift this. The addition of points is basically the subtraction will be this distance total because one of them is they are in the opposite direction as vectors. So this is one vector and this is the other vector. So if we see addition of them will be having or as they are in opposite direction, the subtraction basically means the whole distance. So if we use this, we get this point as well. It is basically using the coordinate geometry in algebraic form. Same with the multiplication. So now we are going to talk about logarithm of a complex number. So what does it mean? So in normal sense, logarithm is a function that basically is opposite of exponential. So if this is the case, we say logarithm of t is equal to x. So it is the inverse function of exponentiating logarithm function. So for a complex number, for example, the famous is log 2 to the base 10. This is 0.3. So log can be of any number. So for example, if it is e raised to x equals to t, then we can say log t to the base a is equal to x. Now when a is equal to t, it is called natural log or ln. When we see a complex number, for example z is equal to r e raised to iota theta, and now we want to take logarithm of this number, that is basically log z is equal to log of r into e raised to iota theta. This basically becomes log r plus iota theta. This is not to be confused with, so if we say mod of log z, it is not same as log of mod z. This is a confusing relation, because if we first take the modulus, it is the under root of x square plus y square, right? Or in this case, it will be r as this m. Modulus of e raised to iota theta is 1. But after taking the log, the number has changed itself. Now the log modulus of log z, it will become log of r whole square plus theta square. So it is not the same as r. So hence, this is an important relation that we get confused in, because logarithms are different. And this is like a question. So we can find it for both in this. So if we see the question, it states that z is given to be 4 plus 5 iota. So if we just find mod z, it would be square root of 4 square plus 5 square. It would be, since we know that mod z is equal to square root of x square plus y square for any number. So this becomes 41. If we see in terms of log of z, just the number, then we need to convert this number into Euler form. So what we do is we multiply and divide by the modulus. So it becomes square root of 41, 4 by square root 41 plus 5 by square root 41 iota. Now we assume theta is equal to tan inverse 5 by root 41. Or we assume an angle theta such that its sine. So sine theta is equal to 5 by square root 41. We assume the number to be this. If this we assume theta to be this value particular, then it becomes square root 41 e raised to iota theta, where theta is equal to sine inverse 5 by root 41. Right? So it basically, now we take the logarithm of this number. So it is logarithm square root 41 plus iota times theta. And this is the difference between log and modulus. So if we now see, this term is basically log of mod z. So now the next topic is cube root of unity. So this is an important topic in terms of how this is a topic in which a lot of questions can be formed basically. So now if we see, this is basically solutions of the equation x cube equals to 1, right? I think we talked about this as well. Yeah, you can see now, right? So this is basically x cube minus 1 equals to 0. We can simplify this as x minus 1 times x square plus x plus 1 from the polynomial formula that we know of like a cube minus b cube. Now we can see that the solution is either x equals to 1 or x square plus x plus 1 equals to 0. This we can say is has two roots, omega and omega square, and they are minus 1 plus minus root 3 iota by 2. It doesn't like, so the notation is not that omega is one number and omega square is the other. They can be used interchangeably, because if you square omega square, right, for example, it becomes omega raised to 4, that is omega cube into omega, and that is, as omega is a cube root of unity, when we cube that number it becomes 1, so that is omega. So both the numbers are interchangeable in that sense. It is just the notation of 1 omega omega square. So these two numbers are interchangeable in the sense that it is not that one is like you know the square of the other, and there is no relation like that. It's basically both of them are square of each other. If you square one number, it becomes the other. It doesn't matter which one is which. So plus minus are interchangeable in that. So now this is the graphical representation of cube root of unity. So as like if we see cube root of unity or any roots in that sense is basically, if we cut the we want to find numbers that are on like equal to 1 or modulus of them is equal to 1, they have to lie on the unit circle. That's basically the key. As if you take any number that we find in cube root of unity, right, it has to satisfy that its cube is 1. So basically its modulus should be 1 as well. Mod. So it lies on the unit circle, basically. Now we know that this is one of the roots that exist, 1 comma 2. Now we want to find two other roots. So basically we divide the circle, as we are looking for cube roots of unity. We divide the unit circle in 3 equal parts. So each angle is 120 degrees. So we find these 2 points. These are the two cube roots of unity. And now the basic properties that we can derive from the definition of the sum of roots and product of roots of a quadratic is basically given, like, I think we know this, but still, if this is the quadratic equation that we talk about, and alpha and beta are its roots, then we can say that alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. So if we compare the original quadratic, the x square plus x plus 1, we compare it with its roots. So it gives us omega plus omega square is equal to minus 1, or we can say 1 plus omega square is equal to 0. And if we say product of them, so it is omega into omega square is equal to 1, or omega cube is equal to 1. But we can also derive from this that omega is equal to 1 upon omega square, and omega square is equal to 1 upon omega. And now we can say that omega square is equal to omega conjugate, and omega square conjugate is equal to omega. This is also a property that we find out. So a lot of manipulation can be done with this two relation that exists as to relations between omega and omega square. If we see the next one, this is now if we see that, okay, The given question is 1 minus omega plus omega square raised to 6 plus 1 minus omega square plus omega raised to 6. Now we know that 1 plus omega square, this is equal to 0, right? But we need to find 1 minus omega plus omega square and 1 minus omega square plus omega. These are the two terms we need to find, right? So now, if we see from this equation, we can find that 1 plus omega square can be written as minus omega, and 1 plus omega can be written as minus omega square. So when we see in these two numbers, we substitute that. It becomes minus omega raised to 6 plus minus omega square raised to 6. This becomes omega raised to 6 plus omega raised to 12, right? It's now this is the power of 3. So this is omega cube raised to 2 plus omega cube raised to 4. Now omega cube is equal to 1. We can basically substitute 1 for both of this, right? It's and this is sorry, this is 2 raised to 6 common because it's 2 omega raised to 6 and 2 omega square raised to 6. So 2 raised to 6 is in common. Yeah. So it becomes 2 raised to 6 as an answer. And into 1 plus 1, 2. So it's the equation's answer is 2 raised to 7. This is now nth root of unity. So it would be better if we use a graph for this one. So let's do the one that we know. So now this is a point of one of the roots. Now as we move k forward. So this is one root, this is second root, this is the third root, and it is now cycling basically. So these are the three roots of so this is the cube roots of unity. These are. Now let's change it to n equals to 4. So the 4 roots should be are the 4 corners of the sphere. Basically 4 roots should be 1 0. So basically it should be 1 minus 1 minus iota iota, or in points 1 0 minus 1 0 0 1 and 0 minus 1. These are the 4 points that should be the output. Let's play. So yeah, as we can see, these are the 4 points. Now let's look at an arbitrary number like 5. So it would be 5 numbers. So one will be here, one will be here, one will be here, one will be here. So it will be a perfect pentagon, basically. That is like, as we can see, like 0, 1, 2, 3. Yep. So it is a pentagon basically. So k is the number of roots. So which root we are talking about? First, second, third, fourth, fifth, that sort of thing. Now all these roots also have one thing in common, is that let's say there are n roots. So they all can be set 1 alpha alpha square alpha to the power n. These are the n roots. right? So 1 into alpha square dot alpha to the power n. This has to be equal to 1 and sum. This has to be equal to 0, right? Also, if there are like, let's say three, we are talking about four roots of unity or like three roots of unity. So this is basically a result that came from x raised to n minus 1. So the generalized result will be sum of any pairs is 0 and product is 1. As so we can say that like 1 into alpha plus alpha into alpha square plus all alpha raised to n into alpha, all of this will be equal to 0 as well. That sort of thing. These are like few properties that we use as well. So this is for the five. So it will be basically dividing the circle in n equal parts with one point being fixed at 1 0. Let's say we move it to 10. So 10 different solutions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 different solutions. And now it is repeating. And the formula is this basically it is came from De Morgan's law. So we can like prove this as well. Kind of like prove it. Because we know that this is the circle and now we divide it in equal angles. So this is theta, 2 theta, 3 theta. So what will happen is let's say you want to divide it in n segments. Let's make it up as a circle. So the first segment, let's suppose this is at theta. Now equal because it is like n symmetrical roots. The second will be at 2 theta and so on. So basically you can say that if theta is the solution for first, all the roots are basically k theta by n. So that is what happens. 2 pi. Why 2 pi? Because the whole thing is divided into a circle. So it doesn't grow beyond the circle. Or we start repeating the roots basically. And because like the total angle is 2 pi. Now let's say you are divided it into n equal segments, right? So it is 2 pi, the each angle will become 2 pi by n or theta is equal to 2 pi by n. And the roots are theta, like 1 theta, 2 theta, up and so on up to n theta. All are the roots. So that is why k theta by n. So it is r in e to 1 into e raised to 2 pi k by n. Now it is basically the polar form of this cos 2 pi k by n plus iota sine 2 pi k by n. So this is our question, right? It is based on nth roots of unity. So it is e raised to 2 pi iota by 7. So if you compare it with the generalized thing, 2 pi iota k by n or 2 pi k iota by n, right? If we compare here, n is equal to 7. So we are talking about 7 roots of unity, right? So the roots will be omega, omega square, omega cube, 1, omega raised to 4, omega raised to 5, and omega raised to 6. These are the 7 roots. Now we need to find, we need to verify that omega plus omega square plus omega raised to 4 and omega cube plus omega raised to 5, omega raised to 6. These are two different roots of the given equation. So for verifying that any two numbers are roots of the equation, we can basically say AB should be minus 1 and A, AB should be 2 and A plus B should be minus 1. It is basically we verify the alpha plus beta and alpha beta. Correct? So now let's find the value of A plus B. So it is basically omega plus omega square plus omega cube plus omega raised to 4, omega raised to 5, and omega raised to 6. This is basically all the roots minus 1. So it becomes minus 1 because sum of roots is equal to 0. 1 is missing. So the sum of roots minus 1 is equal to minus 1. So it checks out as sum of roots should be minus 1. Now multiplication or product of roots, basically omega plus omega square plus omega raised to 4 into omega cube plus omega raised to 5 plus omega raised to 6. Right. So now if we take omega common from this one, 1 plus omega square, omega cube, and we take omega cube common from this one, 1 plus omega square plus omega cube. Right. Now this becomes omega raised to 4. Now, now we multiply basically. So it is omega raised to 6 plus, or we can see that this should be 1 plus omega square plus omega cube plus omega plus omega cube plus omega raised to 4 plus omega cube plus omega raised to 5 plus omega raised to 6. This is omega raised to 4. 1 plus omega square plus omega cube plus omega raised to 4 plus omega raised to 5 plus omega raised to 6 plus 2 omega cube. This is basically this and this. You can see, right? So this is basically we took this and this separate, and the rest is this plus 2. Now this is 0 since we use the same result in above. This becomes 0, so it is omega raised to 4 into 2 omega raised to 3. This is basically 2 into omega raised to 7. This becomes 1 as it is the 7th root. Root raised to the power 7 will become 1. So it's 2. And it's verified because both the results are matching. Correct? This is all I had in mind till now. We can also talk a bit about quaternary. So, right, like we told that, in the last class we visualized that uh, multiplying by iota is basically rotating the vector by 90 degrees. Correct? It's a 90-degree rotation. What iota represents is a degree of freedom. Uh, Multiplying by iota is basically a 90-degree rotation because let's say you take any point 1 and you multiply it by iota, it becomes completely imaginary. So if we see it on a graph, this is 1, and you rotate it at 90 degrees to get it to iota. So it is basically a degree of freedom. Now a 2D object has 1 degree of freedom. Like it can be rotated along counterclockwise or clockwise. But in a three-dimensional space, you have 3 degree of axis rotation or 3 degree of freedom. One, two, and three. So that is why quaternions are considered to be, a three-dimensional complex numbers. So it is complex numbers on steroids. So it is a quaternion number z is equal to a plus bi plus cj plus dk. Now it is looking a lot like a vector. If you guys have heard of vectors, yeah, x y z. Now it is basically, if you have done any 3D geometry, right? We know that if we say that a point is in 3D space, it is considered to be x I cap, y j cap, and z k cap, like, like that, right? So it is I cap, so obviously I cap, j cap, and towards and fro is j cap, right? It is similar, and the notation comes from quaternion. So this is the real part of the quaternion, the number, and this is the spatial degrees of freedom. So where these quaternions are useful in mechanical engineering, basically structures and those sort of thing, and they are also very useful in relativity when we are talking about general theory of relativity, or when we say space time. Because funnily enough, there are three dimension of spaces and one constant dimension of time that has no degree of freedom. So if you want to display space time in a single equation, it is in a quaternionic form. It is t plus a plus b plus c, where this constant number is time. So this is what quaternions are. Quaternions versus, they are called Hamiltonian matrices and Hamiltonian functions and numbers. But these are basically basics, vectors, and elements. So now the discussion becomes a lot about vectors, or when we talk about quaternions, right? They are basically used in physics for rotation. They are, so in general, complex numbers. Now, if we continue as two-dimensional or one-dimensional number, as when they represent rotations. So now if we say take a vector and we want to find, like we want to define the space, 2D space in terms of this vector alone, we can find out the 90-degree vector to it by basically multiplying bit with iota, and then this becomes the basis for the entire space. So that is why iota is very useful in 2D geometry. So now let's say you have two vectors that are existing. You can convert the space into this vector, and now it is easier to do algebra or any sort of problems with this vector. Now quaternions are basically the same approach, but on a three-dimensional space, because now it has three different x, y, and z coordinates. That is basically its relation with 3D geometry. But now if we consider mod of a quaternion, it is basically square root of a square plus b square plus c square plus d square. but it is also like, the determinant of the matrices. So now as we move up the dimensions, the modulus changes its definition to determinant. If we like now different concepts of mathematics that are useful in other parts are now coming into picture. So for example, matrices and determinant and matrices is a different branch of mathematics, vectors and matrices. Matrices are basically a collection that has numbers present in them, like a collection of vectors. And vectors are basically any 3D or any dimensional object. They are So now this is like, a little bit advanced in the sense now it is hard to visualize as we move up the dimension. So for example, we can have a 10 by 10 matrix that in essential or like in theory means that there are 10 dimensions and you are moving the vector in 10 dimensions. But it is very hard to visualize it or use vectors to notate it, like how many I kept, you kept, how many will you go to. So what we do is we built a matrix to keep track of these things. And this is where complex numbers and like matrices and vectors come like sort of combine into each other. Now we can like this topic is over. So what I was thinking about, like, we can do questions of course on the next lecture. We can also start away with calculus if we want, because calculus is a bigger topic. So it will be fine if we take more lectures in calculus. What do you guys think? What should we do? Like, would you want to do questions, or it is better that you just move to the next topic and do a little bit more theoretical stuff? We can obviously do questions and stuff in the next lecture. So the question is basically we got to the end of the lecture. Now we can do like in the next session we can do continue with the questions, right? But it is also possible that we just move forward with calculus and get an extra lecture into calculus. So if like people don't want to do that much of question side of things and just want to learn more of theoretical side of mathematics. Yeah, of course, if people have questions, I agree. We will like I will recap the whole of complex numbers in the next session. So if anyone has any questions, we can solve them. But it's basically if don't have any questions, we can move on to the next topic.